So, I mean, most of you listening to this, they're going to have your definition of what PageRank is, right? I think at this point, it's almost everybody has their own version of it. I will give you the search engineer's version of it and how it works in modern times. No, PageRank is not dead. The calculation exists in the bowels of a lot of other algorithms.
Toolbar or not.
Yep. Toolbar or not, yeah. And so let's just define what PageRank is, and we'll go from there, right? So the PageRank is a probability that a web surfer will reach a given page. That's it, right? So that's really all it's supposed to measure. So, how do we solve that? Well, how does a web server get to your page? Let's pretend that we're talking about one of your pages out there. How does somebody get to your page? Well, that's an easy answer, right? They get to your page either by typing your page in directly into the browser or clicking on a link on another page, and they get to your page, right? Exactly. And you can also use a bookmark, right? There's different ways that you can get to pages, right? And all of these are basically probabilities that you can add up and determine what's the probability that a web surfer would get to your page, right? And we can do this for any page on the internet. So visit all the pages that host these incoming links, right? So we have to go and get these incoming links and figure out what the page rank of that page is, and then divide that by the number of outgoing links on that page. And that's sort of this concept of we want to add up all the probabilities, right, that a person can get to your page. And so the thinking is if we just take every single probability of that person clicking on a link on another page, right? You have all these incoming links. We'll just add up all those probabilities, and you should have a decent understanding of what's the probability that a person will get to your page, right?
Right.
Remember, the surfer could have also just chose to not continue surfing, right? So it turns out that about 15% is something that works well here in this equation. So every calculation will typically add this factor into it as well. We're gonna first have to find the probability that the surfer got to the page with your link on it, right? Because if we're gonna add up all these probabilities of people clicking on these links that are coming to your page, we also have to understand the probability that surfer got to that page in the first place, right? We can use a power iterative method, or formally it's just usually called the power method. And what you're doing is you're assuming an initial probability distribution. That's how you kind of start with this PageRank calculation. And so you're effectively seeding the distribution with this damping factor across all these pages in your link graph. And you're going to iterate over each page's incoming link until the probabilities don't change anymore or past a certain extent. You have to also factor in dangling pages, so pages with no outgoing links in the graph. And this, so there's this nice way to do this by assuming outgoing links to every page in the graph for such pages. And this sounds wildly crazy, but that's essentially what the calculation does. So there's all these tricks in creating this, making sure that this PageRank calculation is working. In fact, you can do the math in many different ways. In fact, you can actually represent these as Markov chains, and where the eigenvector is actually the solution to this Markov chain. It's a very elegant solution, graph solution for that. Instead of just taking the incoming page's PageRank and divided it by all the links on that page, well, it turns out that that's not a very accurate way to do it, right? So certain links transmit more what we call link flow than other links. And this is where it gets very, very interesting because and of course, we say PageRank is dead. The old PageRank is dead, but the PageRank calculation, what it's doing here is it's really kind of remaining in place. But instead of just factoring in these probabilities like they're just divided equally among every other link on the page, we actually start to adjust the edges in this graph, right? So certain edges have a little bit more weight. Come up with a link flow distribution, right? It's a PageRank distribution. We call it at Brew, at our modeling software company, we call it a link flow distribution. And so getting back to making this actual calculation work in a large scale, right? Because it's easy to do, like that web workshop. You put in you add each row, and you have like your
how many outbound links,
right? And you're just adding. But what do you do when you've got literally billions of links that you have to do this across? So there's a lot of ways to actually cheat this equation, right? So we can actually combine graphs. Let's say maybe what we can do is look at an internal link graph of just your site. And what this does is gives us essentially a probability matrix of, if somebody comes to your site, what's the probability they're going to land on one of these pages in your site? And so it's divided up among all your pages. Here's the probability. Now that's not your page ranks, your page's page rank on the internet. You'd have to take that and multiply that into the probability matrix of a domain rank, right? So where each node in the graph isn't a page, it's actually a website. So all the links between each node represent the links between different sites. We're not looking at individual pages here. We're just kind of going up a level and saying, what is the if we treat each subdomain as a node, what is the probability that you're going to land on one of these sites? And so if you take the sort of the broad domain rank and merge it with a more hyper localized graph, there's ways to get the answer out of what you're looking for without having to calculate the broader link graph at the detail that you're trying to do it at. So our modeling software has focused in on what makes a good quality link, and that's sort of gives you the ability to see, hey, I may be pushing the importance of these pages, which give me no revenue, right, as a marketer, and all these competitive pages where I'm not ranking really well, and I need to push more link flow to these other pages. You don't really need to worry about this unless it's a problem, right? So if you're in a search result page and these models tell you, hey, there's a huge statistical gap between these other outperformers in the search results and your target site, well, then that's a problem. And then we have to go and look at things like what we're talking about today, the link flow distribution. How do we get more link flow? How do we get more probability to these pages in the eyes of a search engine? That's all you're looking to do when you're getting a backlink, either whether it's an external incoming backlink from another site, or if it's just it's a backlink, an internal incoming link that you placed inside of the subdomain that you own. They use the Market Brew tool and they look at their link flow distribution and they say, well, I'm having I think your crawler isn't crawling the right way. That is the problem, right? So if the crawler is not crawling the right way, the way that we would standardly, a standard crawl would look like, then implicitly there's something wrong with your link flow distribution. It's always that. So not only can link flow distribution sort of fix the crawlability issues, it can also fix things like where you're a startup and you don't have the budget to go get 10 high quality links from publications and compete with your competitors, but you can reduce the amount of pages in your graph, right, in your site, and push more probability or more linking to certain focused pages where you're trying to compete at, and get more out of your site than you would if you were like, say, Walmart or Home Depot with millions of pages and each page getting just a tiny little sliver of that. Each given backlink structure can only support a certain amount of pages, right? This is just, if you look at the PageRank calculation, and even today in the modern calculation that exists inside of all search engines, including Market Brew, you are going to see that that's just a fundamental truth. Back in the day, we used to call this death of 1,000, not paper cuts, but death of 1,000 pages. And we would see this all the time, where you get a startup that just got funded. They're putting out like thousands of pages, or maybe they found like this automated template, and now they've got like 1 million pages on their site. And they want to rank really well for these like 5 keywords, right? So you just got like 5 landing pages that they really need, and the other million pages are just fluff. Basically. It's just to look like it's a big site.
What was that media company that got slammed when the Panda update happened in 2011 that was producing all that content, making millions of dollars selling that garbage? Right.
And so Panda, so what, we'll diverge here for a second, but Panda is basically an algorithm that took the supplemental index algorithm and weaponized it. It basically said, if you're below this threshold on average of your pages, if you're just not meeting a content threshold with enough link flow coming in, you can't just have 1 million pages in your site. You got to have a certain amount of backlink structure, or we're going to boot this. And not only are we going to ignore it, but we're going to penalize those sites so that they don't do it. So basically, link flow distribution comes down to two main concepts, right? So the distribution, the shape of the graph. And so when you have many links, you have the same problem as these mega menus that go on these sites, where you have 1,000 outbound links on each page just to start with, before you even put the content on the page, right? It's just every page links to every other page. And that gives you a flat distribution, right? So this is a distribution where if we were to add a new page, it would get a very, very tiny amount of link flow, because it's got to split it evenly among all the other pages in that graph. Now, if we want to add a new page that's going to be a page that we need very competitive, we need to have some sort of system where we can just place it in a certain part of that graph, and it automatically gets 5 times more than all the rest of the pages in the site. Okay. And so to do that, we need to have the shape of that graph correct, right? So we need to have a link flow distribution that's steep as opposed to flat, right? Okay. So that's the first thing that you want to use a link flow distribution graph for. Okay. And the second thing is the balance of that graph. So where in that graph does each page fit, right? So hopefully your home page and all your top product pages are at the top of that link flow distribution, and all the non-competitive or lower competitive pages are at the bottom of that link flow distribution. That's not always the case. And so one of the things that companies usually make a lot of money off of right away with our software is they'll just look at the link flow distribution and fix that, right? So you're going to fix the distribution, make it steeper so that it's focused in on all their product pages, and push all the link flow probabilities to those pages, and do the inverse for any pages that were getting a lot of link flow. Maybe your terms of service and privacy policy page was taking like 7% of the probability of all of your views on the site. And while that's great for legal and UI, it's not great from a search perspective. You're telling the search engine that these are things that they want, that you want ranked on their search engine pages. There's no way.
Company history, all of that content, while it's helpful for the user from a link standpoint, could be actually working against you, because now you're emphasizing pages that aren't going to drive revenue.
Right. So it turns out when you're doing these operations, whether you're adding or subtracting link flow to different parts of your site, you really don't have to worry about most of the graph. You only have to look at the top 5% of the graph. And most of the changes, if you just do those to those top 5% of the graph, those pages, the most of the graph will change with it. So in other words, you don't ever have to worry about something that has to be on every single page. It's typically small changes at the top can lead to massive restructure and reordering of both the graph shape and the balance of that graph, where each page is in that graph. Yep. If you think about it, we want to do a search on your site to find the places where we can get link flow with the keywords that we should be looking for. And so there's two parts of this equation. The first one, obviously, is we need to it's another chicken and the egg, right? So we need to have a link flow distribution so that when we go and get the results, we can order it by probability, right? So we need to have already iteratively calculated at least one pass of this link flow distribution on the site to be able to execute this link flow finder. Yep, but once we have that, we can then combine that with the other part of the equation, which is, well, what are the keywords, or what are the entities that I should be linking from or even around to generate more probability out of this link than would be otherwise. Obviously, now we have the ability to pull in all these other things like a knowledge graph, right, and a semantic entity graph to start guiding us to where we might want to put those links, because we have to think about things like topic clusters and topic sort of when we get into Google centerpiece annotation stuff. But so anyway, so the link flow distribution, it's really the fundamental component to any search engine in a modern world. Some takeaways for some people that will actually help you today. If you've got these big mega menus, where you have like 100 plus links, I would say even more than 20 plus links on a menu, is really not appropriate for most of you out there, right?
Unless you're on Amazon or eBay or
yeah, I mean, so we work with some teams that this doesn't apply to them, but in general, the concept really is you want to focus as much of the probability of finding a page in your site from a search engine's perspective. We still call it the page rank calculation. Essentially, it's just got a lot more nuance to it and a lot of more link algorithms in it. Having these mega menus is detrimental to this. It's making your link flow distribution very flat. And when you do that, it's impossible to sort of rank any new page because you're splitting it among every other page in the site, that probability. The first thing you can do is really kind of just eliminate the massive linking on each page, focus in on more of a hierarchy. So really just link to the top pages in your site and let those pages create the hierarchy below them in that part of the site, right? You don't need to find every single page from every other single page in the site. That's just, it's not how the world works. Most people don't even use your search on your website, just to let you know. And if you're an SEO that's struggling to prove this to management, just slap on like a heat map on your site, and you can just show people. It's very easy to see that it's like 1% of probability that people are clicking on links in your navigation in search. And in fact, in our models, one of the link algorithms looks at the number of duplicate anchor text and targets throughout the site. So in other words, it's trying to identify where are the header and footer links and all the other links that are sort of like on every other page. And it actually will lower the amount of link flow. It's lowering the probability appropriately, according to basically our regression models that we built over time, so that those links don't matter as much. Essentially, you could have lots of these types of links, but if they're all the same, if they're in a header and footer, they're not going to transmit as much link flow or probability that the user is going to click on it as, say, like a Wikipedia link, right? Or a link inside of content that might be more applicable for the user. So
I like to look at Healthline quite a bit as I'm thinking about links and link distribution. I know they show up for pretty much every health-related query that you can run. And if you look at their individual pages, there's commonalities in the structure of those pages. There's the short summary that they have at the top that I think they hope will get them the featured answer. There's a little table of contents to guide them to different sections of that page and thinking about how they're using more of the passages and trying to get through, the incremental opportunities. And then the links, their internal links are always keyword rich, pointing to different pages on their website. And their outbound links are set up like footer note links, where it's a superscript 1 and 2 and 3 going out mostly to .gov and .edu pages.
Yeah.
And it's interesting because they rank so well, and I feel like as I'm studying their pages that their links and their link distribution is playing a big role. They must be a market Brew client. They must be.
They probably are. And so the reason I say that is that you can look at this calculation and start to do some really cool things that are both search engine friendly and user friendly. And it turns out that a lot of it looks like Wikipedia. Where we have, instead of having direct links in the content, you have a footer note that it's basically just a named anchor, and it takes you down to the actual link. But the link is in a citation structure. It looks citation, friendly, where you're listing out some other information. It's typically branded. Just a few, but it's that the structure of these links lend themselves to look like sort of not as important as other links on the page. And in doing that, you're effectively, instead of doing things like no follow, you can essentially minimize the link flow going to specific links, but while keeping it not, marked up as no follow, by simply reducing the amount of link flow going through these links. And of course, if you have a link scoring, if you have link scorecards, you can just look at the link algorithms and say, well, how do I induce a link penalty, right? Because of course, link penalties it's a zero-sum game. So you're just pushing the link flow to other links on the page. You're not inherently inducing some sort of page level penalty by doing so. So you can add, you can make a link less relevant via its anchor text. You can make it more reciprocal. You can add more instances of that link throughout the entire site, although that has sort of a negative effect of what you're trying to do, because it can add more link flow if you do it enough. But you can reduce the amount of value going through that link. And one of the ways to do that is what you just described, which is to basically put the link at the bottom of the page in a small script, often not surrounded by any content other than other links and citations.
Or give away anchor text to that other page. Instead, just use a number, like almost like a click here.
Yep. So there's ways where, Google's not going to look at that as like a spammy thing. It's literally just, it's citation structure that's generally used in the scientific community, engineering community. So, we've had a lot of sites come in, look at the link flow distribution, and conclude that was what they were going to do for a given page. Again, a lot of this is constrained. You're thinking that, if you're not an SEO, you're thinking, well, this doesn't make sense. But if you're an SEO, that it's every you've got your UI team that's saying one thing, the legal team saying another. Mm-hmm. So oftentimes you can't do certain things in a straightforward fashion, so you end up with designs like that.
Or your technology group is prioritizing fixes and not marketing. So MarTech isn't a thing still in some organizations. Yeah.
Right.